Let's discuss problem number 8, and this problem was from combinatorics, and this was the toughest problem in the paper, and we have made it more tougher and by generalizing the thing. So first let's understand the problem. So you have like a definition of alternating sequences. So a finite sequence of numbers a1 to an is said to be alternating if a1 is greater than a2, a2 is lesser than a3, a3 is greater than a4, a4 is lesser than a5, and so on. Or it might be like a1 lesser than a2, a2 greater than a3, a3 lesser than a4, a4 greater than a5. Now if you read like this, you won't understand anything, so we have to like visualize how things are happening. And the question is asking that how many alternating sequences of length 5 are there with distinct numbers a1 a2 till a5. And now those AIs can be chosen from 1 to 20. Okay, so this length 5, now we will generalize it for any length n. Okay, and we will like take any n numbers and we'll find that how many alternating sequences are possible with n distinct numbers. Okay, and then from any set you can take those n numbers. And now if you have n distinct numbers, suppose a1, a2, a3, so suppose I arrange them in increasing order, so a1, a2 dot 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 till an, and now I can write 1 2 3 dot 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 till n, and I can simply form a bijection where ai goes to I. And so since it's a bijection, so working with any n numbers is basically the same as working with numbers from 1 to n. Okay, and now coming back to the sequence. So if you see that, first of all let's start with a1, and it says that for this type of sequences like a1 is greater than a2. So here is a1. Now since a1 is greater than a2, so we'll draw a2 below a1 to denote that it's smaller than a1. Okay, and then again a2 is smaller than a3, so a3 will be above a2, and we don't know about a1 and a3 whether like a1 is greater than a3 or a3 is greater than a1. So again about a4, so a4 should be lesser than a3, so it's coming down. And again we don't know about a2 and a4 whether a2 is greater than a4 or a4 is greater than a2. And then again going back to a5 above, and a5 is greater than a4. Okay, and so on and so forth. And so if you draw the whole sequence, it will be like this zigzag form, and starting from above, so it comes down and then goes above, and that's why these type of sequences are known as down up sequences. Okay, because it's coming down going up and then again coming down going up, and so this pattern will repeat. Now coming to the second form, so let's start with a1, and a2 is greater than a1, so let's draw a2 hard above a1, and then again coming down to form a3. As you can see, a2 is greater than a3, and then again going up to form a4. So again a4 is greater than a3, and going down to form a5 as a4 is greater than a5. And so you see that this goes up and then down, up and down, and so these type of sequences are known as up down. So as you saw in the problem, we'll say that a permutation a1 dot 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 an of the set 1 2 dot 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 n is an up down permutation. So up down permutation if a1 is lesser than a2, and then a2 is greater than a3, and a3 is lesser than a4, and so on. And again we'll say a permutation of this a1 a2 dot 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 an from the set 1 to n, down up permutation if a1 is greater than a2, and A2 is lesser than A3, and A3 is greater than A4, and so on. Now in the problem it was asking like alternating sequences of length 5. Now we are working with length n. Okay, now we don't know from where we will take those n numbers. Like in the problem it said that you will be taking those 5 numbers from the set 1 to 20, but it's like first uh, once you choose those 5 numbers and then you see how many alternating sequences you can form those with those 5 distinct numbers, and then it will be similarly for the other 5 numbers as you choose them. Okay, so that's why we are working with n numbers, and we'll see how many alternating sequences are possible with them, and so we can generalize it. So first of all, if you note that if I have two sets where in one set we have those up down permutations, okay, and in the other set we have those down up permutations, and now if we form the mapping, now both the sets are finite. I mean they have finite cardinalities. Okay, and so if I form the mapping, that is if I take a1 a2 an, a sequence, an alternating sequence there. So basically I'm taking an up down permutation. Okay, and I'll be taking it to n plus 1 minus a1 and so on till n plus 1 minus an, and this will give me a correspond one-to-one correspondence between the set of all up down permutations and the set of all down up permutations. And so since they are finite, they are having finite cardinalities, so 1 1 also implies that it's onto, and so these two cardinalities are the same. So then if an is the number of up down permutations of length n, and also the down up permutations will be of length n will be an, as they are equal, and so the total number of alternating sequences of length n is 2an. And now using the definition of this an, we will try to make a recursive relation, and thus we'll try to solve the problem. Now if you consider a permutation, that is an alternating sequence a1 a2 an, so since it's a permutation of the numbers from 1 to n, so one of them will have to be equal to n. So let ak be equals to n. Now why did we suddenly take this number n? Like why are we suddenly interested in who is taking n? Because n is the maximum number, right? Out of 1 to n, n is the maximum one, and whoever will be taking that, the neighborhood points will be lesser than that, and that's why from there we can like understand the behavior of the alternating sequence, whether it's up down or down up. So let's see. So from here it implies that ak is greater than the previous one, k minus 1, as well as ak is also greater than the next term, so ak plus 1. Yes, now if ak is a1 or an, then the other point won't, like if a k is 1, then ak minus 1 won't exist, and if k is n, then ak plus 1 won't exist. Okay, fine, but now we'll consider two cases. So case 1, when k is even. So if k is even, then let's again go back to the diagram. ak minus 1, ak plus 1, and now notice that the whole thing is an alternating sequence from a1 to an. Now we'll consider a partial sequence of it. So from A1, starting from A1, we'll consider till A k minus 1. So if you look at this, then if as k is even, so k minus 1 will be odd. And so from starting from A1, we are considering till A k minus 1. Now the next term, the previous term, A k minus 2 will be above, and then AK minus 3 will be below, and so on, and it will go on. But how do we understand that at the beginning A1 is starting from above or below? Now as we know that here we have odd number of terms, since k is even, k minus 1 is odd. So you see, start like from a k minus 1, if you go up, so a k minus 2, and so if it ends like going back, if it ends above, then you are going to have even number of terms, right? But if it ends below, then you are going to have odd number of terms. And so since you have odd number of terms, so a1 will start from below, okay? And so then after that it will go up and so on. So this will be an up down permutation, okay? And for the next one, like from a k plus 1 till dot 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 an, this sequence will be like from a k plus 1, it can't again go down because the whole thing is an alternating sequence. So from a k plus 1 it will bounce back to a k plus 2, and then it will go down and then go up, and this one will be an up down sequence because it's starting from a k plus 1, then going up and then going down. And so again this will be an up down sequence, okay? Now of length k minus 1, how many up down permutations do we have? According to the definition, if the length was n, then it's an. So if the length is k minus 1, it's k minus 1. And again here we have this length is n minus k. And so the number of up down permutations of length n minus k will be a n minus k. And now again similarly let's analyze for case 2 when k is odd. So coming to case 2, k is odd, and so let's again draw the diagram. So here we have a k minus 1, a k plus 1, and now again things would go up from here. So if we look at from a1 till a k minus 1, so now k is odd, so k minus 1 is even, and so now the thing would end above, okay? If you go backward, it would end above. So a1 will be starting from above, and it will come down and then go up and finally end at a k minus 1. So this will be an down up sequence. And so how many down up sequences of length k minus 1 are there? A k minus 1. And now if you analyze the rest, that is from a k plus 1 till a n, now it's again the same. It's starting from a k plus 1, it goes up and then it will come obviously down and then go up. And so this is an up down sequence. And so how many up down sequences are there of length n minus k? So it's a n minus k. And now let's combine case 1 and case 2 to find out how many alternating sequences of length n are there. So the number of alternating sequences of length n is 2an, because the total number of up down permutations is an and down up permutations is an. So together total number of alternating sequences are 2 times an. And now if we combine case 1 and case 2, and if we sum that up for k starting from 1 to n, so first of all, you see that for the first group, we need k minus 1 numbers. Okay, and the number n is already taken by ak. So rest we have n minus 1 numbers, and from there we need how many numbers for group 1, that is k minus 1 numbers. So how can we like take it out? In how many ways we can do that? It's n minus 1 choose k minus 1 ways, right? And for each such choosing, you obviously are left with n minus k numbers, and that goes to group 2, okay, for case 1 as well as case 2. And so it's n minus 1 choose k minus 1. Now we have like chosen numbers for the two groups, and now for the first group we can make such sequences in a k minus 1 ways. Okay, so there are a k minus 1 sequences, and for each such sequences we have a n minus k sequences for the second group. Okay, and that combined case 1 and case 2 together, we have this result, that is 2an is equals to summation k going from 1 to n, n minus 1 choose k minus 1, a k minus 1, a n minus k. And now you would like to know that when k is 1, then we have here a0. Now if you look at the sequence a1, a2 dot 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 an, when k is equal to 1, so that means a1 is n. So a1 will be above, and then it will come down to a2 and so on. And so from a2 it will go up, okay. And if we look at the sequence from a2 to an, then it's an up down sequence, because it's from starting from a2 it's going up, and then it will go down, and then and so on. So it's an up down sequence. And how many such up down sequences are there? A n minus 1, because this length is of n minus 1, so a n minus 1. And so since when k is 1, so this will be a n minus 1, and a k minus 1, that is a0, will be initialized as 1. And similarly, when we will have k to be equals to n, so that means the two extreme possibilities, that is in this case a1 a2 dot 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 an, so here an is n. So since an is n, so finally it's ending above, and so an minus 1 and so on. So as you can see that sequence of length n minus 1 can be made in a n minus 1 ways. And now the next one, that is a1, will be equal to 1, because if you have only one number, with that number you can make only one sequence, and so a1 is 1. And now for our problem, what we have to find out is 2 times a5, right? Because like we need to find out that given any 5 numbers, how many alternating sequences can we make out of it. And so now we have to do some recursive calculations based on our recursive relation and the two initial conditions. So if we calculate out 2a2, that will be equal to 2 and a2 equals to 1. So similarly 2a3 will be 2a2 plus 2a1 square, which is equal to 4, and a3 equals to 2. I'm not doing a detailed version of this calculations, so as you can do it because you have got the relation, so you just have to plug in the numbers. So 2a4 will be equals to 2a3 plus 6 a1 a2 and that will give you 10, and A4 equals 5. And finally, what we wanted, 2A5 is 2A4 plus 8 A1 A3 plus 6 A2 square will be equal to 32. And so if we have any 5 distinct numbers, we can make 32 alternating sequences. And now the problem was asking us to choose 5 distinct numbers from the set 1 to 20. So how many such 5 distinct numbers from 1 to 20 we can choose? It's 20 choose 5. And for each such choosing, we can make 32 alternating sequences. So in total, 20C5 times 32. And that's the answer, and we are done with problem 8.